Hello, I'm Mr. McChesney, and today we're going to try and figure out how to find the mass of an atom. So the problem we have is the operator of a mass spectrometer produces a beam of doubly ionized, which would be 2 plus neon atoms. They first are accelerated by a potential difference of 34 volts. Then as the ions pass through a magnetic field of strength 0.050 teslas, the radius of their path is 53 millimeters. Determine the mass of the neon atom to the closest whole number of proton masses. So that sounds like a lot of things to do, but first let's draw kind of a sketch. So here we have our voltage source, and our ions path are shooting into this magnetic field, and you want to determine which way they curve. So when you do this, you use your right hand rule. You point your thumbs in the direction of the magnetic field. So you see we've got a magnetic field that has these X's, and that's supposed to be like you're looking at the tail end of an arrow being shot away from you. So that means the magnetic field's going into the page. So if you point your thumb in that direction, when you curl your fingers, the direction they curl shows you the direction that the ions will curl. So they curl in this direction. And then we have the radius labeled of how much the curve is, and then we have the strength of the field being shown by the letter B. So as we start, we've drawn our picture there. Now we're going to label everything we know. And we know we've got 34 volts. We've got a strength of a magnetic field, which was 0.050 teslas. And then the radius was curved 0.053 meters. So you can see I've converted 53 millimeters into meters by doing dimensional analysis, which you've seen before. And we got a couple things we also know that aren't given to us in the problem. So we know the mass of a proton, and you can find that by usually looking at tables that are located in the back of your book. 1.67 times 10 to the negative 27th kilograms. We know also the charge of our particle, and since it said it was doubly ionized, or 2 plus, when we do this, we're going to take our charge and multiply by 2. So the charge is 1.60 times 10 to the negative 19th coulombs. And that's going to give us a charge of 3.20 times 10 to the negative 19th coulombs. So now that's everything we know. The things we don't know are we don't know the mass of neon, which is what it asks you to find. And you need to know the mass of neon, so that's something we don't know, so that we can figure out how many protons are in that mass. Alright, so let's find the mass of neon. So if you look early in the chapter, you find this equation: charge divided by mass of the atom you're looking at. In this case, since we're talking about actually an ion, it would be the mass of the ion. So it would be Q divided by M. It's going to be equal to twice the voltage divided by the magnetic field squared and the radius that the curve path follows through the field squared. So I want to get mass by itself. And so when I do that, if I just take Q and I divide by Q and put it onto this side, most of the time what happens is I'm going to get 1 over M, but students will just leave that 1 over part off and say M is equal to 2V divided by B squared times R squared divided by Q, which will give you the wrong answer. So I'm going to flip all the fractions on this. So I'm going to take everything and inverse them, which is going to give me the mass of neon divided by Q is equal to strength of your field squared, magnetic field squared, times your radius squared divided by 2V. And now I can take and multiply by Q on both sides. If I do that, I cancel it out on the side with the mass of neon, and we'll be left with the mass of neon equaling the magnetic field strength squared times the radius squared times the charge divided by twice the voltage. So, if we plug our numbers in now, we get that our field strength was 0.050 teslas. Don't forget to square that. And then you're going to multiply that by the radius, and our radius was 0.053 meters, and we're going to square that, and then we multiply that by the strength of our charge. In this case it's twice the charge of a proton, 3.20 times 10 to the negative 19th coulombs, and then we divide that all by 2 times our voltage, which was 34 volts. And again, when using graphing calculators, if you don't put a parenthesis around these numbers, you won't get a correct answer. So this is going to come out to be the mass of neon is equal to 3.3 times 10 to the negative 26, and mass should be in kilograms. So that's our first answer we need. Whoop. Let me just highlight that for you. So our first answer now comes the question that you're really trying to answer. How many protons is this mass? So that's the N protons. So in order to find this, if we know the mass of our neon, and we divide out the mass of a single proton, then we should be left with how many protons we have. So we take our number we just found, 3.3 times 10 to the negative 26 kilograms divide that by the mass of a proton, which if you look up at the top, you find it was 1.67 times 10 to the negative 27th kilograms, and that's kilograms per proton. So that's going to give us kilograms canceling out. Then we'll have 1 over proton, which means we'll have an answer in protons. And so I'm going to draw a little plus sign here to represent the proton. The number of protons ends up being 20. And it's protons. Is that a reasonable answer? Look at your exponents. You have 10 to the negative 26, and you're dividing by 10 to the negative 27th. And when you divide exponential numbers, you subtract them. So negative 26 minus a negative 27 gives you a positive 1 power. So this is 20 would be 2.0 times 10 to the positive 1. So that seems like a reasonable answer. So here's our final answer, 20 protons, which if you look on a periodic table, you'll find that neon has isotopes that are 20 or 22. So 20 is a reasonable number.